Have a good day, everyone. We will discuss about pulse code modulation, or in short, PCM. But first, we're talking about modulation. What is modulation? Modulation is the process of varying one or more parameters of carrier signal in accordance with the instantaneous values of the message signal. The message signal is the message signal is the signal which is being transmitted for communication, and the carrier signal is a high frequency signal which has no data but is used for long distance transmission. And now, we were focusing on pulse code modulation. Pulse code modulation is used to digitally represent sample analog signals. It is the standard form of digital audio in computers, CDs, digital telephony, and other digital audio applications. The basic concept of pulse code modulation is divided into three parts: the sampling, the quantizing, and encoding, which will be discussed as we go along. But this process is important in PCM because it converts analog signal to discrete signal and eventually to digital signal. And it is the important to note in PCM. A signal is pulse code modulation to convert its analog information into binary, sequence, series, or progression, as denoted as ones and zeros. The output of PCM will resemble a binary sequence. Instead of pulse train, PCM produces a series of numbers or digits, and hence this process is called as digital. Each one of these digits, though in binary code, present the approximate amplitude of the signal sample at that instant.
And now, we will proceed to the block diagram of pulse code modulation from transmitter to receiver, having three sections, which consist transmitter, channel, and receiver. First, we're focusing on the transmitter section. From analog message signal, it is an ordinary voice message conveyed directly from a speaker to a hearer by pressure changes in air. It's an analog message because the pressure changes are continuous. The pressure varies smoothly up and down to create sound. And going to the low-pass filter, it used to filter the noise, which is our higher frequency signal. When passed through a low-pass filter, most of the noise is removed and produce clear sound, as simply as this filter eliminates higher frequency component. After that, we take a piece of data from the whole data, which is continuous in the time domain. This is called as sampling. The process of measuring the instantaneous values of continuous time signal in a discrete form. And also, we reduce the excessive bits and confining data from sampled output, reduces redundant bits, and compress the value when given to quantizer. After quantizer, the output of pulse code modulation is go to the channel through encoder. It designates each quantized level by a binary code. The digitizing of analog signal is done by encoder. And through generative repeater, the output of the channel can increase the signal. Same for regenerative circuits. It can save the time and energy from increasing extension speed and to compensate the signal loss and construct the signal and also to increase the strength. And now, we will proceed to decoder. The decoding of a message signal is like on how an audience member is able to understand and interpret the message. It is the process of interpretation and translation of coded information into a comprehensible form. And also the decoder circuit diodes the pulse-coded waveform is reproduced the original signal, just the process of recovering the signal intelligence from a modulated carrier wave, also called as the modulator. The last part of block diagram through the section of receiver is the reconstruction of filter. When the digital to analog conversion is done by the regenerative circuit and the decoder, a low-pass filter is employed to get back the original signal by using reconstruction filter.
And now, you've heard all about the information about pulse code modulation. I hope this video helps you to determine the different function in every parts behind the sender to receiver. I hope you like and share our video, and if you have some comments and suggestions, comment down below. And that's all. Thank you.